Well, this is the last video for MTH060, and this is going to be a review of what we've done over the term. To do that, I'm just going to go over the questions from the sample final, which I posted to the course website. And it goes in the order that we covered the material during the term. So it starts out with these questions about percentages. So remember, if you're working with percentages, you can think of this as is over of equals percent over 100. Or you can think of this as, what do we do here? The percent as a decimal. Times of equals is. Okay? And so the real question is, what's is, what's of, what's the percentage? Here, the percentage is as a whole number. Okay? And here you have to put the percentage as a decimal. Okay, so let's look at problem number 1. It says a concert venue has 3 separate parking lots. Parking lot A holds 64% of the total number of parking spots at the venue. If lot A can hold 1,488 cars, how many parking spots are available in all 3 lots together? So the question is, what are we working with? We can see 64 is the percentage, so we'll go ahead and put that into our problem as the percentage. Let's see, now the question is 1,488. Is that is or is that of? And remember, another way to think about this is that is the part and of is the whole. Okay? That's another way to think about percentages. So the question is the 1,488 the part or the whole? Well, it seems pretty clear that if there are 3 separate parking lots and one of them holds 1,488 cars, that's a part. Okay, that's not the whole parking for the venue. All right, so that 1,488 has to go in the numerator. Our x goes in the denominator, and we multiply these two and divide by 64. So let's go ahead and do that. 1,488 times 100, and then divide by 64. And our answer here is 2,325. Okay, so that's problem 1. Problem 2. This is a discount problem, okay? And these are a little bit tricky, so let's talk about this. So the computer is advertised at a price of $528, marked down 12% from the original price. What was the original price? So what we're saying about this situation is that and you don't have to solve the problem this way. This is just a way to think about the problem. We had some price P. We found 12% of P, and then we subtracted it to get 500 and ended up with $528. Okay? So this actually can help you to solve the problem, because if you think about it, what you've got here is 1p minus 0.12p, and that's going to be 0.88p. Okay? This will actually solve the problem for you. If you divide on both sides by 0.88, you'll get the correct answer. So that's one way to think about it. What I'm about to say now is this, just in different terms, right? So if you're working with a discount problem and you're given the sale price and the percent that it was marked down, the way to do this is to do 100 minus 12 is 88%, and then know that this is 88 88% of the original price. So the original price is of, 528 is, and this will be 88 over 100. And so then we multiply these two and divide by 88. Like I said, it's exactly the same process as this. This is a little bit, I guess, harder to understand maybe, leans a little bit heavier on algebra. So let's see, if we go 528 times 100 and then divide that by 88, turns out it originally sold for $600. Okay, that's problem 2. Problem 3. A student has an assignment to read 64 pages in a textbook. If the student has read 20 pages, what percent of the assignment has been completed? Well, we're looking for the percentage. Okay? That's what we're looking to find. Now the question is, what's is and what's of? What's the part? What's the whole? Well, the whole assignment is 64 pages, and the part of it that's been completed is 20 pages. Okay? All right, so now that we've got that set up, we're going to go 20 times 100, and then divide that by 64, and x is 31.25%. And really, unless the problem asks you to round off a number, you really shouldn't. You should just leave it the way that it is. Okay, so that's problems 1, 2, and 3. That all has to do with these ideas about percentages. If you want to write something like this to help yourself remember how to work with percentages on your note card, then I encourage you to do that. There will be some formulas on the final exam, and the sample final should give you an idea for what you'll have on the actual final and what you won't, and then you can make decisions about what you want to put on your note card. Okay, problem 4 is a proportion. A 40-acre field yields 600 bushels of wheat. So 40 acres gives you 600 bushels. At the same rate, how many bushels will a 75-acre field yield? So 75 acres gives you how many bushels? And there are a variety of ways to solve this problem. And I talked about this in the videos when we were covering this topic. But something you can always fall back on is a proportion, right? 40 acres gives you 600 bushels. 75 acres will give you X bushels. And remember, it's important to set up your units in alignment with each other, right? These are the bushels down here, these are the bushels down here. If you want to set the acres up with the acres, right, in the same fraction, that's fine, but make sure that your 40 acres corresponds to the 600 bushels and the 75 acres corresponds to the X bushels. That way, notice we multiply 75 times 600 and divide by 40. Same thing here. 75 times 600 divided by 40. So let's see what that comes out to be here. 75 times 600 and divided by 40. So X is 1,125 bushels. Okay. Problem 5 is about a unit price. So let's see here. Problem 5, 16 gallons. Of gasoline costs $46.24. How much does 1 gallon of gas cost? Then we need to, the cost per gallon, that word per means divided by, so we want to take the cost and divide it by the number of gallons. 46.24 divided by 16. So 1 gallon is $2.50. And you can solve this as a proportion if you'd like, right? You can say 16 gallons is $46.24. 1 gallon will be X. And you'll see 1 times 46.24 divided by 16, and that'll give us the $2.89. Okay, problem 6 is a little bit tricky. Okay, so in this one, this combines the idea of units and conversion of units as well. So let's see here. I need to find a conversion. Oh, for these yards into meters. Well, if I did this to you on the final exam, then I would have to take that into consideration, because I put this question on here without any conversions, okay? So we need to have that, when it comes time for the final exam, you will have the conversions on the test paper for you. I don't have them right here, so I'm just going to do the best that I can. So let's see what we can do here. So the problem says Jane can run 100 yards in 9.6 seconds, while Paula can run 100 meters in 10.8 seconds. And the question is, who is the faster runner? So that's why we have to convert these units so that we're comparing the same units to each other. Let's see here. Let's see here. Okay. So the conversion I'm going to use here is that 1 meter equals 3.28 feet. And like I said, I need to put these conversions on the test paper for you so that you don't have to worry about these issues like I am right now. Okay, so if 1 meter is 3.28 feet, then let's convert the 100 meters into X feet. And notice that I line the meters up on the tops, and I line the feet up on the bottoms. And let's see here. So 100 meters is going to be 328 feet, right? 100 times 3.28 divided by 1. 328 feet equals 100 meters. Okay, this one is 300 feet, right? 100 yards is 300 feet. So this person runs 300 feet in 9.6 seconds. So how many feet per second do they run? Now we have to do the dividing. 300 divided by 9.6 is 31.25 feet per second. Okay, this one, this person runs 328 feet in 10.8 seconds. So 328 divided by 10.8 is approximately 30.37 feet per second. And that says that Jane is the faster runner, right? Because she's going 31 feet per second, Paul is running about 30 feet per second. So Jane is a little bit faster. Like I said, that's kind of a tricky problem. The one I think on your final won't be quite as tricky as this, but whatever it is, I'll make sure that you have the conversion factors that you need to solve it. Okay, Well, let's keep moving. Okay, problem 7. If an 80-pound bag of fertilizer covers 6,000 square feet, so 80 pounds covers 6,000 square feet. How many pounds of fertilizer do I need to fertilize my backyard, which is measured at 120 feet in length and 150 feet in width? So we need to know how many square feet are in that rectangular backyard. So we do 120 times 150, and so this is 18,000 square feet. And we can set up a proportion, or you can just look at this and see we're going to need 3 bags. So what does it ask? How many pounds? Okay, well we need 3 of these bags, which is going to be 240 pounds. So there's the answer right there. To solve this with a proportion, we would say 80 over 6,000 is going to be x over 18,000. And if we do 18,000, let's see, 18,000 times 80 divided by 6,000, that gives us the 240 pounds. Okay, so this is a proportion question, but you did have to find the area in square feet for that backyard. Okay, now we get to the section with the positives and negatives. So, problem 8. -6 plus -8. So I like to restate this with just a single sign. So remember that when you add a negative, that's the same as subtraction. Okay? And you can do this yourself. You can use the calculator. If you're at -6 on your number line, this minus sign takes you further out into the negative numbers, another 8 places, and that'll leave you at -14. Let's see here, problem 9. 9 minus -15. Again, I'll restate this as 9 plus 15. And, you know, that's a pretty straightforward problem, but I'll look at it on the number line anyway. We start at +9. The plus takes us that way, 15 places, and that should leave us out there at +24. Problem 10. -5 times -7. Okay? Notice the difference between the addition and subtraction problems versus the multiplication problem. Okay? When this number is written right next to a parentheses like that, that means times. Negative times negative will be a positive, and that'll be a +35. Let's see, 11/32 divided by -8. That fraction bar means divided by. And so 32 divided by -8 will be -4. Okay, problem 12. 2 minus 7 squared minus the square root of 49. Okay, so we want to work inside the parentheses first. 2 minus 7 is -5. And then -5 squared. You really have to be careful here, right? Squaring something means to multiply it by itself. When you multiply -5 times -5, you'll get a +25. Now, something that happens to people sometimes is they go to their calculator and they type in -5 squared, and the calculator tells you that's -25 because the calculator is doing this. It's doing the squared part first, okay? So it's squaring that 5 and then applying the negative. What you want is -5 squared in parentheses, okay? That means -5 times -5, and that's positive 25. So please don't do that. Make sure that you understand what happens when you square a negative number. You're going to get a positive number. And then we go ahead and finish this off. Positive 18. 25 minus 7 is 18. Okay. We've got one more in this section. Problem 13. We've got 5 times negative 4 plus 3 minus 15 over 3 squared minus 6 times 8 minus 17. Okay. So let's see. 5 times negative 4 is negative 20 plus 3 is negative 17 minus 15 on the top. On the bottom, this is 9. 6 times 8 minus 17, what is that? That's going to be negative 9. Okay. Now here's the thing. Remember the order of operations, right? Whether you remember it the way that I do, or whether you remember it some other way. A lot of people use the PEMDAS to remember that you do parentheses first, and then you do exponents and roots, multiplication and division, and then addition and subtraction. What I'm saying is that this multiplication right here, negative 6 times negative 9, has to happen first before you do 9 minus anything. Okay? So, negative 6 times negative 9, positive 54. Negative 17 minus 15, negative 32. And so this is negative 32 over, let's see, what is this? Positive 63. Does that reduce? I don't think it does. That's it. And we can just leave it like that. Okay? If you want to divide it out and write it as a decimal, that's fine too. But the key is to make these calculations correctly. Okay. Let's see what else we got here. Problem 14. Express 54 as a product of prime factors. So I'll do this 2 different ways. One way you can do this is you can split this up. Okay, we just saw 54 is 6 times 9. The 6 is 2 times 3. The 9 is 3 times 3. Here's our prime factors. You can write this as 3 times 3 times 3. You can write it as 3 to the 3rd power. Doing this is correct. Doing this is correct. Doing this is correct. You don't have to do all of them. Just make sure that you do one of them. Okay. So that's one way to go about doing this. The other thing that you can do is you can take the 54 and say, well, let's see. I know that this is an even number, so let's divide it by 2. And that'll give you 27. Hopefully you recognize 27 is divisible by 3. That'll give you 9. Divide that by 3. And then here's all your prime factors. So that's another way to go about factoring a number like that. Okay. Let's see where we are here. Okay, so now we get into the algebra problems. Problem 15. Let's see, negative 7x plus 12xy. And we know that x is negative 7.2, y is 3.6. Okay, so we need to make some substitutions and some calculation here. Let's see here. So this is negative 7 times negative 7.2, and then 12 times negative 7.2 times 3.6. Alrighty, well, let's multiply these two together. Negative 7 times negative 7.2 is positive 50.4. Let's see, I'll hold off on that sign until I multiply these, because if we do 12 times negative 7.2 times 3.6, we're going to get a negative 311.04. And then we do 50.4 minus 311.04. And that gives us negative 260.64. Okay. There's problem 15. 16a squared plus 6ab, and we want a equal to 9, b equal to negative 5. Okay, so 9 squared, and then 6 times 9 times negative 5. So this is going to be 81. And this will be minus, what is this? This is going to be 270 here, right? There's 30. 30 times 9, 3 times 9 is 27. 30 times 9 is 270. And we've got a positive times a negative. So in the end, we'll have a negative. So now 81 minus 270. Oh, what is that going to be? Like 191. That's my estimate. Let's see how close I get. 189. I sometimes do that, go in the wrong direction. So negative 189. Okay, problem 17. What do we get? 6x minus 3 times 5x minus 2 minus 9x. So, this is about combining like terms. If you remember when we covered this topic, I encouraged you to look at this in pieces, right? You've got one piece here, one piece here, one piece here. These two are just going to stay there. You can combine them together if you want and make a negative 3x. That's fine. But really what we need to do is distribute this 3. Multiply it here and here. So we'll get minus 15x plus 6. And now we can combine like terms. Let's see here. This will be 6 minus 15 should be negative 9x. Minus 9x makes negative 18x plus 6. And that's it. Okay. All right. Let's look at problem 18. We've got negative 5x squared plus 3x minus 4 minus 7x squared minus 12x minus 9. Okay, so in the first parentheses, there's nothing in front of this parentheses, so we can just take the parentheses off and nothing changes. Here, this minus sign has to get distributed into the parentheses. So this will be minus 7x squared plus 12x and plus 9. All right, now we want to group our like terms. That's negative 12x squared and positive 15x. And then negative 4 and positive 9 plus 5. And there we go. That's it. You can't add the x's to the x squareds. They don't work well together. And so we just leave them the way they are. Okay. Now, problems 19 and 20, we have to solve equations. So 19, we get 12 equals 3 times 5x plus 2 plus 9. All right, so what we want to do here is simplify things. We need to distribute this 3 into the parentheses. 15x plus 6 plus 9. Oops. So 12 equals 15x plus 15. Okay, well, what I'm going to do here is I'm going to subtract 15 on both sides. So 15x equals negative 3. And notice that the x is getting multiplied by 15. So if I want to get the x by itself, I have to divide on both sides by 15. This is negative 1/5. If you take your calculator and do negative 3 divided by 15, you'll get an answer of negative 0.2. Either one of these answers is fine. Not a problem. Okay? All right, that's problem 19. Problem 20. 2 plus 5 times 3x minus 1 equals 7 minus parentheses x plus 2. Okay, so here we've got a couple things to do first, right? We're going to distribute this minus sign into the parentheses over here, and we're going to distribute this 5 into the parentheses over here. Don't fall for this. Don't try to add 2 plus 5. We saw a similar thing a couple problems back. You have to do the multiplying first, okay, before you do any adding or subtracting. So, 2 plus 15x minus 5. Over here, 7 minus x minus 2. Okay, so this is 15x minus 3 equals negative x plus 5. Okay, right? This is a positive 2. This is a negative 5. Together they make negative 3. All right, I'm going to collect all my x's over here. I'm going to collect anything that's a constant term that doesn't have an x on the other side. So let's see, that's 16x minus 3 equals 5. And then we'll add 3. 16x equals 8. And again, the x is getting multiplied by 16, so we have to divide on both sides by 16. X is 1/2. You can call it 0.5, but don't call it 2 because that's not correct, right? If you do 8 divided by 16, you'll get 0.5, or if you reduce it as a fraction, you'll get 1/2. So I'm not saying that all of your answers will be fractions, but don't be surprised if some of them are, okay? It's important to be consistent and not at the last second decide that you don't like an answer that's less than 1, and so you're going to make it something different, okay? Sometimes your answers are less than 1, and there's nothing wrong with that. Okay, problem 21. We want to find y values for the given x values using the formula y equals 2/5 x minus 7. So let's see, we've got x values of negative 5, 0, and 10. Okay, so we're going to take our x value of negative 5, plug it in there for x, and then calculate. 2/5 times negative 5 is negative 2, minus 7 is negative 9. There we go. All right. Next, 2/5 times 0 minus 7 is 0 minus 7, which is negative 7. And then the last one here, 2/5 times 10 minus 7. Let's see. 2/5 times 10, that should be 4 minus 7, negative 3. And that's all we're asking for in this problem, is just to find those y values. Okay. So problem 22 is a graphing problem. So let me make a quick graph here. Okay, let's see. So we want to plot the points -2, -5. So remember that these points are always in the form x, y. and the x's are the horizontal, and the y's are the vertical. Okay, so the point -2, -5 says go over to -2 and go down to -5. Okay. -4, +6. So that says go out to -4, go up to +6. And the last one, +3, +1, go over to +3, go up to +1, and there we go. Okay? All right. Let's look at problem 23 here. Problem 23, we have a rectangle cut out of a circle. The shaded portion is what's left in the circle after you cut that rectangle out. The rectangle is 4 by 6 inches, 4 by 6 inches, and the circle has a diameter of 9 inches. Which says that the radius, which is what we need to calculate the area, is going to be 4.5 inches. Okay? So, that's an important thing to think about whenever you're working with a circle. If you need to know the area, you're going to need to know the radius, and so you want to double check whether or not the problem's giving you a diameter or whether it's giving you a radius. If it gives you a diameter, just cut it in half. Okay. All right, so the whole circle is going to be pi r squared. So pi times 4.5 squared. Let's see here. Pi times 4.5 squared is, it's going to be about 63.62, we'll call it. And then the area of the rectangle is length times width, or 24 square inches. So to find the area of the shaded region, we want to take the area of the whole circle, subtract out the piece that's missing, 63.62 minus 24, and what's that going to be? 39, it looks like. 39.62 square inches. Okay. One more problem. So this is very similar to those area and perimeter problems that we were doing for week 9 here. We've got a rectangle. We know the area is 1,200 square feet, and we know the perimeter is 140 feet. Okay, we want the same perimeter but a smaller area. Okay. Okay. Now remember that the biggest area comes from a square, as long as we're working with a four-sided figure. Okay. So the biggest area for this perimeter is going to be a square that has a perimeter of 140 feet. So what are the lengths of those sides? Well, take the 140 and divide it by 4. Okay? I think that's going to be 35. Yeah. Okay? So the biggest area is going to come from this square that's 35 on each side. Okay? And that area, let's see, 35 times 35 is 1225. Okay, so we need to get a smaller area than 1200. So let's shift some of these lengths here, okay? So let's take 5 away from these and add it to those. So that'll be 30 here, 30 here, and then 40 here, and 40 here. Still got a perimeter of 140, but now our area is 1200. All right, we need to go even smaller than that, right? To get a smaller area, you want to add on to the longer side. So let's take 10 from here, add it on to the longer side. So now we've still got a perimeter of 140, but this time the area is going to be 1000. And the problem asks us for the length and the width, and so that's 20 by 50. Or you can say, length equals 20, width equals 50. Whatever you do, that's what we want. Is we want the dimensions of this rectangle that still has a perimeter of 140, but has an area that's smaller than 1200. Okay. If you want a larger area, you want to be going towards a square. So if they give you something like this and ask for a larger area, then what you want to do is you want to take away from the bigger side and add it onto the shorter sides, right? That's the opposite of what we did here. All right. Okay, so that's it. That's what your final is going to look like. I'll post this along with this video to the course website. If you have any questions as you're looking this over, please let me know. Otherwise, I will see you next week for the final exam.